right, so number one, Maya, show me, what did you get on your equation? What's your answer? Say up there. Okay, very good. What I want you to be thinking about is, how could you have gone from these solutions back to this equation? There's a little trick to this. If you know the solutions of a quadratic equation, you can look at the sum and the product, and using that information, you can go back to the equation. So that's what we're going to be looking at as we go through this. All right, so what about number two? Natalia, what are your answers for number two that you got in the warm-ups? Okay, so she got 2 and 5. All right, and then what about number 3? Charlie, what did you get there? 1/2 and -3. Okay, 1/2 and -3. And then on the last one, so on the last one, Amrisha, what did you do to figure this out? All right, very good. So this would have been our equation. And as an equation, we have to say y equals or f of x equals. If you don't say equals, it's not an equation. You cannot just have that. All right, so now let's look back up here. The sum of these two, if I add these two together, I get -1. If I multiply these two together, I get -6. I want you to be thinking, how does this sum and product lead us back to this equation? Okay, let's keep going. The sum here. What's the sum of these solutions, guys? And what's the product? Good. So how does this sum and product relate back to that equation? So let's just look at these two for a minute. Can you think of a way that if I told you the sum and I told you the product, that you could come up with the quadratic equation? Let's go back down here again. What's the sum of these two solutions? What's the sum of these two, guys? -1. And what's the product? -12. What is the relationship? What if I told you this? If the sum of the two solutions is 8 and the product is -4, you should be able to come up with the equation. Do you think they could do it based on this pattern that we're seeing? Yeah, what do you think, Natalia? You are correct. Okay. So now I want us to think about, how did she get that? Natalia, can you expand on that and tell me how you got that?
Well, the sum is usually the x, but it's the opposite of it. So if it were -1, then it would be plus x, plus 1x. And then the product would be the last number, so it's -4.
Very good. She's right. How could you write then that rule? So if A and B are solutions to a quadratic equation, I want to know what was the quadratic equation, or what is the quadratic equation? What's the rule on it? So if A and B are solutions to a quadratic equation, what is the quadratic equation? Can you do it with A and B now? Natalia just showed us what it would have been with, if I gave you the sum and I gave you the product. Think for a second about what would the formula actually be. Sydney, do you read it up? Like that? Well, actually, it would want to be like this because remember how the sum of the two numbers always goes in front? So wouldn't a plus b give us the sum of the two numbers? It would, wouldn't it? So we could say it's going to be x squared, but we always said that it has to be the opposite sign. So it's going to be minus a plus bx. And then what's the last thing going to be, though? What do we do to a and b? Michaela? Yeah. That'll work, won't it? Okay? So that would be a formula we could use. We could also write it a different way. It's just x squared minus, what's the word for this? Sum, difference, product, quotient. So it's x squared minus the sum of the two equations times x plus, what is this? Product equals 0. This is an equation, either one of those two forms, that we're going to be using quite a bit. The reason we're going to be using these is because look at the method that we used on number 4. We did x minus our first solution, which we're calling a, and we did x minus our second solution, which we're calling 3, right? And we multiplied that all out. That's great. That works just fine. But what if the solutions had been really difficult solutions? Like, what if my two solutions were x equals 1 plus radical 3, and my other solution was 1 minus radical 3? And I have to come up with a quadratic equation with those solutions. I would then have to do x minus this solution times x minus this solution, based on what we did in number 4. Think about how difficult that is. I would have to do this, and then I would have to FOIL this whole thing out. I'd have to distribute the x through every term, and I'd have to distribute the negative 1 through every term, and then distribute the negative radical 3 through every term. I'm going to end up with 9 terms. That would take a lot of work. But if I just look at these two and I say, what's the sum of them? What do you get if you add these two guys? One plus radical 3 plus 1 minus radical 3. What is it? 2. There's the sum. For the product, I do have to FOIL these because they're binomials. So 1 times 1 is 1. The outers would give me negative radical 3. The inners would give me positive radical 3. What's radical 3 times radical 3, guys? 3. And so what's the product going to be here? It's going to be negative 2, isn't it? So if this is the sum and this is the product, what would the equation be? Raise your hand if you can tell me the equation based on that sum and that product. Michaela? Good. So that would be the equation that would have these solutions. Maybe you don't trust me. Let me solve this by completing the square. I would take that 2 over. I would take half of this and square it, add it to both sides. This is x minus 1 squared. This is 3. I'd take the square root of both sides. I get x minus 1 equals plus or minus radical 3. I take this over. That's 1 plus or minus radical 3. Can you see how I do get those solutions that we said we would get? Okay? This is a very important formula. It's going to save us a lot of time on problems like this where we have solutions that are radicals or complex. So you want to write this down somewhere, one of those two, whichever form you think is the most helpful for you.